And indeed, I should have mentioned that in the southern hemisphere, the river plumes are deflected to the left. Okay, so they move to the left. And it's important knowledge if you do some coastal planning, stuff like this, That's important. So let's have a look at the last type of front that we have, the so-called upwelling fronts. Upwelling fronts, it sounds confusing a little bit because an upwelling front is created by upwelling, but the front itself actually has downwelling features. Anyway, so upwelling front, and this is one example. These are measurements of temperature front, upwelling of the lower air peninsula. Okay, and you can see this is a vertical section, and 12-degree water moved into the surface layers near the coast. Okay, and you can see horizontally there is a big change in temperature. 12 degrees on one side, 19 degrees on the other side. Okay, and so this is a front, and we know that the upwelling jets actually run along these fronts. So we have a frontal current, which is the upwelling jet, and creating eddies and stuff like this. Okay, this is what we call upwelling front. All right. Okay. So what's one of the last things is just looking into semi-enclosed estuaries. Okay, like this is positive estuary. We talk more about estuaries. Essentially, positive estuaries are systems which include low salinity river-derived water near the surface and open ocean seawater-derived water depth. You have a salinity stratification, and on both sides at the banks of the estuary, the tides can produce tidal mixing fronts, which is shown here in a sketch. Okay, you have tidal fronts, and then you get tidal frontal currents running along the banks. You get convergence zones running along the parallel to the banks of an estuary. So that's already it. Well, it was a monster lecture, I have to admit. But okay, so what type of fronts can we see? If you were in summertime, just South Australian waters, let's have a look on the shelf. And what we find, we actually find a number of fronts here on the southern shelf. Okay? We, for example, find upwelling fronts and shelf break fronts. The red dashed line is the shelf break, and this is sea surface temperature. Here just from something like March, okay, of a selected year. No, this is not March. This one is February. Okay, I can see February here. Anyway, end of February. Bonny upwelling you can identify here. Shelf break front. Upwelling fronts. You can also see the water that's formed in the western Great Australian Bight, running along the shelf break, coming from the northwest. Okay, and it's a broad feature because of the eddies it produces. We also get some passive fronts that are actually created because colder water is moved along the entrance of Spencer Gulf. Okay, so this is the upwelling creates this feature here. And one thing which is not seen as hard to see is actually in Backstairs Passage. It's this area here. There's actually a tidal mixing front. Okay, and the tidal mixing front in this area, because the tidal currents can be very strong. They're 2 meters per second, very, very strong tidal currents, creating mixing here in this area. Can be often seen in satellite images. All right, key understanding questions. What are oceanic density fronts? So what is it? Okay. What are the general dynamical features of density? Okay, because they all share the same features. Why are fronts ecologically significant? Okay. Can you explain different generation mechanisms of density fronts? Can you? I learned about 3 or 4 different mechanisms. All right. So next lecture, we talk about estuaries, definition and classification of estuaries. And I hope that you enjoyed that monster lecture on density fronts. But anyway, these are all facts, all known features, and it's good to know about them. Okay, so see you later.